So today what I want to look at is some operations with vectors in space. Again, we're looking at connections between what we've already learned with two-dimensional vectors and what we want to do with three-dimensional vectors. Okay? So, operations with vectors in space. First of all, let's define the basic operations that we looked at with two dimensions. First of all, the vector addition, okay? How did we add two vectors when we were in two dimensions?
So x1 and x2 and z1 or y1 and y2.
Okay, add the x components, add the y components, and you've got a new vector with the sum of those. Well, when you have three components, like here vector u is ABC and vector v is DEF, you simply add the x components, the y components, and the z components. Alright? So, same concept, we just have that third component that we need to make sure we add. Likewise, we also had scalar multiplication. If we had some number, k, a scalar, times a vector, like k times u, in two dimensions we distributed the k to each component. Well, we're going to do the same thing here in three dimensions. We distribute the k to each component of our vector. Now, what does multiplying by a scalar do to the vector?
Increase the magnitude.
What does multiplying by a scalar do to the vector?
Increases the magnitude.
It increases the magnitude. It multiplies the magnitude, right? This is what we saw here. The magnitude of a vector times a constant is simply the magnitude of the original vector times that constant. Alright, so if vector u has a magnitude of 10, the magnitude of 7 times u is going to be 7 times 10. Okay? And then remember there's no division, there's no scalar division. We would simply multiply by a reciprocal. Okay? I know that's a technicality, and I know that you could kind of make it work, but we want to make sure we're doing things properly. So don't put vector u divided by something. It should be times 1 over that number. Okay? So let's try a little bit here. Okay? We have vector u is 3, 8, negative 2. Vector v is negative 4, 6, 5. And first of all, I want to just add those two vectors together. So, what would u plus v equal?
-1.
Okay, 3 minus 4 is negative 1.
14.
14, 8 plus 6 is 14.
3.
And negative 2 plus 5 is 3. Good. Okay? So again, you're just adding the components. We just happen to have 3 of them now. Okay. Let's think about this. What would 3u equal?
9, 24, -6.
Okay? You guys all with me here?
Yes.
3u? 9? 24? Negative 6. Alright, I know it's easier to just let 1 or 2 people give all the answers, but it's a lot better for you if you actually try. Alright? Here we go. So, we have 3u. What's 2v? Good. Negative 8? 12? And 10. Okay? So now we subtract. 9 minus a negative 8,
17.
17. 24 minus 12, 12. And negative 6 minus 10, good, negative 16. Okay? All right. Questions so far? Now let's see what you remember from Friday. We gave you how to find magnitude on Friday. Magnitude of U. Someone want to tell us how to do magnitude of U?
Isn't it just the square root of u squared plus m squared plus negative u squared?
Exactly, okay. Remember, in 2 dimensions, we derived it straight from the Pythagorean theorem. Okay, put it away. Three squared plus 8 squared. Now we just have this z component. Now it's negative 2, so we're going to throw that in there as well. Negative 2 squared. Alright, so 9 plus 64 plus 4, 77. Square root of 77.
What is the formula? On the magnitude of the magnitude?
For 3 dimensions, the magnitude of u is the square root of a squared plus b squared. That was 2 dimensions. Now we have a third component, so it's a squared plus b squared plus c squared. Alright, so now, without finding what 5u is, what's the magnitude of 5u?
5 times 76.
Yeah. 5, the magnitude of 5u is the same thing as 5 times the magnitude of u. So that's 5 root 77. Okay, now I want to talk about real quick why this is useful. Okay, this property in particular, why is this useful? If I were to find the magnitude of W, and W is 48, negative 72, and 24, I can square those, okay? I can square those, square root of 48 squared, that'd be 2304, okay? Plus whatever 72 squared is. Okay, plus 24 squared, which that one is 576. What's 72 squared?
5184.
5184, okay. And if you figure that out, that ends up being, what is it?
24.
Not exactly. It's like 24 root 14. Is that it? 24 root 14. Okay. But we're getting some big numbers, and simplifying the radical, if your calculator doesn't do it for you, can be kind of a pain. Alright? We can get there a little easier by rewriting W. Can someone see a way where I could rewrite W as a scalar multiple of something else?
Factor out a 24.
Okay, factor out, you see a 12 with your multiplication tables. Really, we can take out a 24. If you took out a 12, all the result would all be even still, so you could take out another 2. But yeah, if you take out a 24, we have 24, and then the resultant vector here is 2, negative 3, 1. Okay, and I don't know about you, but to me, squaring 2, negative 3, and 1 is a lot easier than squaring 24, 72, and 48. Okay? So what I have here is I have 24 square root of 2 squared plus 3 squared plus 1 squared, and that's 24 root 14. You get the same thing either way, but this is something to look out for that can kind of make things a little simpler for you. Keep your numbers smaller, less of a chance to make a mistake. Okay? Yes?
Can you do the same thing with 2D vectors? Or no?
Yes. Yeah, you can do the same thing. You can do it with any vectors. Alright, so that's the first thing. I wanted to make sure we defined our operations for three-dimensional vectors. Now, let's look at another concept that we actually did not really do with 2D vectors, although it applies no matter what they are. And that is, we can do some algebra with vectors. Okay? Let's say that we know what this result is, W, and we know it's going to take 3 U's and 2 V's to get W. Alright? And we know what U is, but we don't know what V is. Alright? So what would we have to put in for V? Well, we can use algebra to solve for vector V. And the nice thing is you can do algebra almost the same way you would anywhere else. For example, here, the first thing I would do is subtract 3 vector U. So I'd get 2 times vector V equals W minus 3U. Okay? And then
You could solve.
we don't divide because there's no scalar
multiply by
division,
half.
right?
Multiply by half.
Alright, so we'll multiply by a half on both sides. And we get vector V equal to 1/2 vector W minus 3/2 vector U. Okay, so then if you knew what W and U were, you could figure out what V was going to be, or needed to be. Okay?
Could you do the vector W minus 3 vector U first and then just multiply by half instead of...
Yeah, I mean, you could leave it with the 1/2 outside the parentheses, it's fine. Right. Try this one here. 5 times the quantity U minus V equals W. Solve it for V. Okay. What'd you guys get?
Vector V equals 1/5 vector W minus 1
Minus what?
vector U.
Okay, good. Good. Right off the bat, we could multiply by 1/5 and get U minus V equals 1/5 W. And then if we add the V and subtract the 1/5 W, we would get to what you see here. Okay?
Isn't it
Isn't it flipped?
U minus 1/5 W?
Oh, yeah. We got our signs up.
Just
Mixed up.
negative, yeah, negative.
There we go.
Yeah.
Oh, shoot.
Yeah, there we go. Now, could you distribute the 5 first? Yeah, you can. 5u minus 5v equals w. And then you could w minus 5u. But then when you multiply by a negative 1/5, this cancels out to a positive 1, and here's where you get your minus 1/5. So there's more than one way to do it, but either way, that's what you would get v to be. Okay? So, any questions about that part? Pretty straightforward? Alright, I know we haven't done that before, but wanted to make the connection here. Now, back to a couple things we have done before. Finding unit vectors and getting a vector to have the magnitude we want it to have. Alright? So, we want to get a unit vector that's parallel to the vector 2, 8. Remember that for parallel vectors, basically the idea is they have the same direction or opposite directions. In other words, one would have to be a scalar multiple of the other. Okay? If I want a unit vector parallel to 2, 8, what do I have to do first? We did this before with 2 dimensions.
Find the magnitude.
Find the magnitude, that's right. The magnitude of 2, 8. You guys know this, square root of 4 plus 64, so it's a square root of 68. Okay? And that is 2 root 17. Okay? So then what do we do with that magnitude? Very good. We take 1 over 2 root 17 and we multiply the original vector by that, because remember that'll keep it the same direction. Constant multiples keep it the same direction but change the magnitude. Here we're multiplying by the reciprocal of the magnitude, so it'll make our magnitude 1. Alright, so we have 2 over 2 root 17, which the 2's cancel out, and that's just root 17 over 17 when I rationalize it. And then we have 8 over 2 root 17. 8 over 2 is 4, and then you rationalize, so it's 4 root 17 over 17. Okay? Alright, so what do you think we're going to do for it in 3 dimensions? Same thing. Find the magnitude, multiply by 1 over it. Okay?
Bless you.
So tell me here, what's the magnitude for 12, 10, 6?
280.
Square root of what?
280.
280? 144 plus 10 plus 36. Okay? So square root of 280. And we're going to leave it in radical form, okay? That would be 2 root 70. And 70 is 2 times 5 times 7, so that doesn't simplify at all. Alright, so 2 root 70. Okay? So then we do the same process here. 1 over 2 root 70. We're just multiplying it by a 3-dimensional vector here. 12, 10, 6. So we've got 6. 12 over 2 is 6. 6 root 70 over 70. And then 5 root 70 over 70. And then 3 root 70 over 70. And we should reduce if we can. So 6 over 70 would be 3 over 35. So 3 root 70 over 35. That's 1/14. So root 70 over 14. And that one doesn't reduce. So 3 root 70 over 70. Okay? So that's a unit vector that's parallel to that. Okay? And these are not only parallel, but they're parallel and going the same direction. If I had them parallel going the opposite direction, what would happen?
Just negative.
It would just make them all negative, yeah. Okay. Good, good. You guys are making the connections well, so that's good. Now, one thing we did last unit was we would find this unit vector and then we would multiply it by something to get the magnitude we wanted. Here what we're going to do is we're going to do it all in one step, okay? So we just looked at this, the unit vector in the same direction is the vector times 1 over the magnitude. I mentioned that you could do this last unit, but we still did this kind of in 2 stages. Now I want you to get more comfortable and get used to doing it all in one step. If I want it to have a magnitude of k, then I'm going to multiply the vector by k over the current magnitude. Alright? So you can think of it like this. You do vector v times, okay, the magnitude you want over the magnitude you have. Okay? That helps you make sense of it. Alright? We're multiplying it by whatever the magnitude you want over whatever the magnitude you have is. And this can be helpful, especially like if you currently have a magnitude of, say, 8, and you want the magnitude to be 24, well, if you think about it, 24 over 8 is 3, so really you just have to multiply the vector by 3. Okay? If you triple it, it's going to go from 8 to 24. Alright, and it kind of just takes one step out of the process, which eliminates one more opportunity to mess something up. Okay? So, just a connection there, again, that we want to make. Alright? Now, I gave you some to practice with here. Here's some with vector equations. Just solving those. Try a few of them. Okay, I know there's a lot here, and some of them have, like this one has 6 parts. You know, if you think you've got it down pretty well, try like the last 2. Okay? Here's some getting used to dealing with different notation and whatnot. This kind of uses some logic as well. Remember, what do these little marks mean? What does that mean?
They're equal lengths.
Yeah, they have the equal lengths. Okay? So from A to B, B to C, C to D, and D to E, it's all the same length. Okay? Alright, here you have some other stuff. Writing one vector in terms of some others. Okay? And then just some other vector operations stuff. Alright? So give those a try. Come in with questions tomorrow.
I will forget.
And Have a lovely day.
So this is your fee for letting.
Gotcha.
go back in.